Okay, these are the problems from 13.1. Problem 13 is probably the hardest of all the problems that you guys need to do for this assignment. So I'm going to spend a little time on it. Basically, you have to look and you have 3 points. You're given 3 points, A, B, and C, and you have to tell whether they're collinear or not. Well, if they're collinear, then that means they lie on a line, and one point is between the other two. Now, at this point, we don't know which point is between the other two, but I would like to say that this distance here from, between 2 points plus this distance here equals the whole thing. So what I'm going to do is I'm going to find the distance between all three of the points, between A and B, between B and C, and between A and C. And I'll see if, any two of them added together equals the third distance. And if that's the case, then I'll have this situation here. And if that's the case, then they will be collinear and one of the points will be between the other 2 points. All right, so let's go. At this point, see, that's the tricky part. Now it's just, this gets a little humdrum. Okay, so the distance from A to B. So, we have the distance formula, the square root of, the sum of, the squares of, the differences of, the x and the y coordinates. So here we go. 0 minus negative 2 squared plus 3 minus 1 squared. And now we just got to do the grunt work. And I think I might make this a little bigger. Focus in a little more. Okay, there we go. All right, so 0 minus negative 2, that's 2 squared. 3 minus 1, that's 2 squared. That's 4 plus 4, which is 4 times 2. Now that's interesting. The reason I'm doing that is because I do want to simplify this. I could have gone, this is 8, and 8 is 4 times 2. This is an alternate way to do the same thing. And then square root of 4 times 2 is just square root of 4 times square root of 2, which is 2 radical 2. So there's one way to do this. Here's a second way to do the same thing. So I know the distance from A to B, point A to B, is 2 radical 2 units. Okay, I got to find the distance from point B to C now. Okay, so here we go. Negative 2 minus 3. There I go. Difference in the x's. 1 minus 6. Difference in the y's. Got all this stuff around it. Square root of, the sum of, the squares of, blah, 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 blah. Okay. So negative 2 minus 3 is negative 5, quantity squared. And then 1 minus 6, negative 5, quantity squared. So this negative 5 quantity squared is 25. Again, 25. Square root of 25 plus 25, which I recognize as 25 times 2. Remember, addition is just a series, or multiplication is just a series of additions. All right, so 25 plus 25 is 25 times 2, and then that's 5 radical 2. So that's BC. Got to do it one more time here. AC. So my point A is 0, 3, and my point C is 3, 6. So the difference in the x's is 0 minus 3. And now we have the difference in the y's, 3 and 6. 3 minus 6, and all this other stuff around it. Okay, 0 minus 3 is negative 3. 3 minus 6 is negative 3. Those guys both have to be squared. That's 9 plus 9. By now we're used to this little trick. That's 9 times 2, and that's 3 radical 2. So now I have these three values. I have 2 radical 2. That's the distance between A and B. I've got 3 radical 2. That's the distance between A and C. And I notice that 2 radical 2 plus 3 radical 2 equals 5 radical 2. So I say to myself, oh, that means that AB plus AC equals BC, i.e. 2 radical 2 plus 3 radical 2 equals 5 radical 2. Therefore, A, B, and C must be collinear, and A must be between points B and C. So here's the picture. AB is 2 radical 2, and AC is 3 radical 2, and together they have to equal 5 radical 2. So, you kind of have to play with the order of the points till you get them right. Okay, so that's the hardest problem on the whole assignment. That's 13. 25, here we go with 25. All right. So you are given a circle and you need to graph it. So this is what you're given. So remember, this is the equation of a circle. X minus h quantity squared plus y minus k quantity squared equals r squared. So it's clear from the pattern that h is 3. Also clear that k is negative 4. The reason it's negative 4, the pattern goes y minus k, and here I have a y plus 4. Well, how do I get a y plus 4? That's y minus a negative 4, so k is negative 4. And then I know that r squared equals 36. If r squared equals 36, then r is 6. So now I have the center of my circle, hk, 3, negative 4, with my radius of 6. So now I just got to draw it. Okay, great picture that I did here. 3, negative 4, there's the center. And then in order to draw it, I'm just going to go out 6 units this way. That's one radius length, so there's a point that I know for sure is on the circle. 6 units up this way, 6 units over this way, 6 units perfectly vertically down this way, and then I just, try to draw the circle. It's a sad little circle. Oh well, I did my best. Okay, so that's 25. 35 is a problem where you're given the center of a circle and it passes through the point 614. Now, I know that this drawing isn't perfect. It's not even on a coordinate system, but we can all appreciate here's the center, 0, 6, and here is the point 614. So let's just agree that that's what that is. What you'll notice here is because the circle passes through this point, this distance between that point and the center is a radius long. So in order to get the equation of a circle, I need to find the radius length. Well, I can do that using the distance formula between this point here, 614, and the center. And then once that's step 1 in my problem, then once I have the radius, then I can use the center to get the equation of the circle. So let's find the radius first, okay? So the distance, the radius, okay, this is what I'm finding. The distance, I want this radius here, is, 0 minus 6. There we go. Difference in the x's. And here's the difference in the y's, 6 minus 14. So it's the square root of, the sum of, the squares of, the difference in the x's and the difference in the y's. All right? 0 minus 6, 6 minus 14. 0 minus 6 is negative 6. 6 minus 14 is negative 8. Now look at here, folks. We remember that these are the legs of a right triangle. So you don't even have to bother to solve this. You can say, oh, this is 6, 8, 10. But if you don't like that, then, let's do the math. Negative 6 squared is 36, plus negative 8 squared is 64. So 36 plus 64, that gives you 100. Square root of 100 is 10. So 2 ways to look at it, same thing. This is 6, this is 8, this is 10. Let me just throw in parenthetically. Suppose this had been 5 and this had been 12. You wouldn't have to do all the arithmetic. You could automatically say this is 13 because that would be a Pythagorean triple. So this is where you look for the Pythagorean triples. 6, 8, 10, 5, 12, 13, 7, 24, 25. Okay? Now, back to this. So I know that the radius is 10 units. So I have the radius, I have the center. Now I can just write the equation. I know that the radius squared is equal to x minus h, here's my h, is 0, quantity squared, plus y minus k, I know my k is 6, quantity squared. 10 squared is 100, x minus 0 squared is just the same thing as x squared, and then I have plus y minus 6, quantity squared. So this is the equation of a circle that has as its center 0, 6, and it passes through the point 614. And that's it.